Great, we're on. Okay, hello everybody. Welcome to the March Showcase. And for those of you that have not been here before, this is a space where we all the projects at Wildlife AI share their progress from the month prior, celebrate their wins, and showcase all the achievements that we've done. My name is Carolina, and I'm the product manager for the Wildlife Watcher project, which is the project that we are starting with. So let's start with the update about the project objectives first. We are developing a smart camera with the ability to capture all animals, including cold-blooded and invertebrates, capturing good quality images to be able to tell the species apart, and identifying certain species with an on-camera AI models. And then conveying the results via cloud and real-time notifications to the user. And we also want the camera to have a low power consumption and to be affordable. And where we are right now, we are actually at the end of MVP 1, which is the first use case of capturing images of a gecko. And the team has done an incredible job to get us to this place where we have a working camera that can sense movement, take pictures, saves them, and allows us to process them. And the camera is controlled by a mobile app that we use for deployment setup. So we have some very exciting demos coming up for you. So without further delay, let's just move on to the demo agenda. Dev will start with a brief run through the camera setup and talk about the mobile app. And then Charles will explain the hardware and how the different components fit together and connect, and then demo the motion detection. And finally, we have Tobin that will show us how the data is saved, how it's all structured and stored, and what we do with it. So how those images are then that we capture are then processed. So Deb, I might pass over to you to share your screen and walk us through a quick demo.
Yeah, definitely. Sweet. I hope that you can hear me well. So let's start with sharing the screen. So my name is Dev. I'm a biologist and also a data scientist here with wildlife.ai in charge of the geckos. So testing anything that could be hardware, that could be software, and also setting up everything regarding the data science part. So regarding the previous things that we have, so I will just show you quickly the current stage of our mobile app. See here, this is two recording of my screen. So the first one is in regards of the registering and also the logging. So right now we have a running app on iOS and Android where you could, when you are launching the app, do the registration and also log in if you already have an account. So during the registration, you have to put few different fields. All those fields could be mandatory or not. In that case, with the small red stars, it's mandatory. So you have to put your username, email address, the password, and everything. And the application will just register you and will allow you to get those information. Please don't take a look at the password. It's not a strong one. It's just for different testing purposes. Definitely put a stronger password. And then when the register is done, you arrive on the main page of your mobile application. So it's really a modern application where you have like the small hamburger menu, you have like your profile and everything. And the first thing that you will notice in the scanning elements and deployments. So the goal as a biologist using those camera traps and using this mobile app is really to arrive in the field with this PCB, which is like the first MVP. So inside the case, there is the camera trap, and I will let Charles talk about it a bit later on. But I arrived on the field with that, and I use one of the magnets to do the Bluetooth advertising. And when I'm doing this, the mobile app that is scanning all the surrounding to find the device will just start to scan for the exact device. So this is the second sharing screen. So here you can see that it's scanning everything. I did the Bluetooth advertising, and in a couple of seconds, you will have this device, which is mine. When you're entering into the configuration device setup, you will have all the information regarding the device. So first of all, you have a command line. You can enter a few things. You will receive few information regarding the device. So this is the first step, the first communication with the device. And you will have everything set up at the first third of your screen. And then after this first third, you have like a bunch of different buttons that we are putting in place. So you have action buttons. This is, simply put it, this is just a way to run few command lines without thinking about it. So if I want to reset the device, if I want to erase everything on the SD card, if I want to disconnect it, you have a bunch of quick action buttons that you could use to communicate really easily with the device. Again, the goal with wildlife.ai is really to make the experience for those who will use this camera trap to be the smoothest possible. We want them really to have instant connection with the device and be able to quickly run stuff without properly, for example, understanding anything regarding the command lines. And then you have like a bunch of information regarding the ID of the device name, the version of the firmware and everything, the battery that would definitely be useful, and a bunch of things that you can definitely use and check when you are in the field. So a few information regarding the device right now. And when the configuration of the device is done, you can go back to the main page. And inside the main page, you have all the deployments that you did. So we have for now, we have 4 different tabs, and we are on the tabs of deployment. So this is where, as a biologist, I will go in the field and start to deploy my camera. So I can add a deployment. I have the list of all my different deployments. And when I'm adding a new deployment, I'm starting that deployment by giving the project that I'm currently working with and giving a deployment name. When everything is done regarding the configuration of the deployment, I can definitely take a look at the different tabs, for example, the maps, the project, and the device. So it's still a work in progress. Project and device is still under creation, if I would say. But the goal for us is mostly to go in the field, deploy the camera, get some images, created projects, connected a different bunch of devices, and have everything linked together. So I could have, like different devices, and those different devices will be linked to different projects. Let's say that I'm working on Teano or Taranaki High. I just like working with the different perspective of finding different type of geckos, for example. I can have a bunch of devices linked to a bunch of different projects and have everything on the map to check all of those devices that are working at the same time. And this is mostly about the application. The goal for us, the next goal is really to improve those user stories and make sure that we get connected with people that are on the field and get a ton of feedback from them. So yeah, that's it for the mobile app. And yeah, KK, you can just jump in and start to share your screen again. If you have any questions, of course, let me know.
Thanks, Steph. Great. That was amazing. So now we can pass on to Charles and hardware. So Charles, if you wanted to, I won't share my screen yet in case you wanted to show some stuff, and then I'll share my screen when you're ready.
Okay, thank you very much. So yeah, so I'm Charles Palmer and I'm managing the hardware on this project, and Caroline has already at the beginning identified some of the design requirements in terms of remote operation and low power and inexpensive and so forth, and in particular the need to observe exothermic animals, those with the same temperatures as the background. So 3 parts of my presentation to have a look at the hardware requirements in light of those goals that Caroline has set up, to look at some of the consequences of that in a little bit of detail, and then finally to show a short video of the device in operation, demonstrating some of those features. So if we just let me wave a device at you on the screen in case for those of you who haven't seen it. It's a single printed circuit board, and we'll look at these two processes in a moment. And if I turn the board over, here are the two cameras that we're going to talk about. This is a Raspberry Pi camera, and commercially available, lots of different types. And then this little motion sensor camera here, this little one right at the end of my pencil. So this board's operating, and a few people have got one, and we're developing the software and getting things working step by step. Some of the requirements that come out of when we consider what we wanted to achieve is the low power operation, and it turns out with and an inexpensive operation, and that rules out lots of processors that might be small and inexpensive like Raspberry Pis, because they're just too power hungry. It turns out that there are a lot of microprocessors which can be very low power, but in order to achieve your lowest possible power, it's useful if the processors can be asleep almost all of the time and only wake up when it's essential. And since we want to do neural network processing, that in general is a lot of maths. It turns out that if you can find a processor which has got an integral neural network processor, then that operation can take much less time, just a millisecond or a couple of milliseconds, and that allows the whole device to go back to sleep really quickly. So, Carolina, maybe you'd like to pop up the block diagram on the screen. We've found tell me when it's there because I can't see it yet. Okay, so we found a processor which is an ARM microprocessor. It's the large square on the right-hand side labeled HX6538, and that is at its core has two important blocks. One is a standard ARM microprocessor, but the other important part is the block above it shown as a neural network processor. And the software can hive off the neural network calculations into that block, and they can be performed very quickly. You'll see that we've got two camera interfaces, and they're on the right-hand side, and I've already indicated those to you before, and then an SD card socket, so we can capture the images and put them onto an SD card. Now, that's the block on the right-hand side there, and so with that amount of electronics, we can capture images, store them on a card, perform neural network processing, and go back to sleep. We probably want a couple of other things to happen. As Deb has indicated, we want some kind of user interface for configuring the device, and what we've implemented here is a block on the left-hand side, which has got another ARM processor, and one of those blocks within that second processor is a Bluetooth radio. And then the other radio, the two little tree-like structures at the top indicate antennas, one for the Bluetooth and the other one for a radio technology called LoRaWAN. Now that's a very low power, long range radio communication scheme. It's not suitable for transferring pictures, but it is adequate for transferring metadata, like I think I've just seen a rat. And then a variety.
Oh no, we lost Charles.
Switches and so forth. Optional blocks shown at the bottom there are a GPS location, which probably won't use, accelerometer, which we could possibly use, but it's there if we need it. Radar block. Two points to talk here about the way that we can detect motion. We want the processors to stay asleep. Normally, if you were looking for mammals, you could use a PIR motion sensor, and these look for warm blocks of images moving across in front of your sensor. That won't work with geckos or invertebrates. So on the first weather watch, we used a radar, which was very effective. We've got an option for a radar in the system. Well, we've not implemented it yet. What we are doing, and what I'm going to be able to show you in a moment, is the second camera, which is a motion detect camera. Now, this is quite an interesting device. It comes from the same company that provides the neural network processor, and it's designed for
Okay, we lost Charles, unfortunately. Maybe let's give him a minute. Yeah, there it goes. Sorry, Charles, you dropped off, but you're back.
I don't know what's happened there. Am I back again?
Yes, yeah, we can hear you.
So the motion detection camera is everything else can go to sleep, and the camera actually goes into a mode where it monitors the difference in the images between successive frames. And if something moves across the field of view of the camera, then there's a difference that can be detected. And then the camera can wake up the rest of the processor. The processor can take the picture, perform the neural network calculation, and take some action upon it. And that's our how do you say, our plan A for the motion detection in this device. If for some reason we decide we want to go back to the radar, then that remains an option as well. So that's the hardware really that we've got working at present, and a good deal of the software is functioning on it. A good deal of the functional blocks are there and tested, and the objectives now are to flesh that out and get it doing real things in the field. So I put together a little demo of the motion detection, and maybe I'll just finish now by going away and we can watch the video.
Thank you, Charles. Let me know that you can hear the video, just if there is sound.
I think the video is saying there's no sound. I can talk through it if you like. If you can't get the sound, I'll just talk.
Oh, actually, no. I can get the sound. I can get the sound. That's okay. Let me start again.
This is the camera that's sitting up. I'll shut up. You go.
Quick demo of the WW500, particularly showing off the motion detection feature, but also the neural network. At the top, the small device there. In the middle, the black device is the HM0360 camera with motion detection. And as I moved in the sight of that motion detector, you'll see that the LEDs are coming on. The green LED indicates that the processor is awake. Let me move my hand again in front of it. The green LED indicates that the processor is awake, and the blue LED is indicating that it's capturing an image and processing it. It does that 4 times and then goes back to sleep, enters a deep power down mode in which the whole system is drawing very little power indeed. Now if I move in front of the device, you can see the motion has triggered the camera again. Show you what's showing up on the screen. There's a lot of debug messages, but the thing to note there is the green text that says person detected. This is the output of the neural network model. Now at the very bottom right now it says entering DPD mode. I'm not moving in front of it, and so it's in a deep power down DPD mode until I move again. So the neural network is invoked every time it takes a picture, and in this particular case the model in the WW500 is detecting people. If I move again, you see the device wakes up again, starts taking more images. I move off to the side so it can't see me, and those green messages will transition into red messages which are saying no person detected, and then it goes back to sleep.
Amazing. Anything to add, Charles? I think that was great.
I think that's probably enough for me.
Perfect. Thank you so much for this presentation. And now the third part of the process, we have another recording just because of the unstable internet from Tobin. So I think it's safer if we just play this video. And then Tobin, if you wanted to add anything, you can do so at the end. But I'll just play another video now. I love how the transcription thinks that all of this is me talking. So I sound very smart. Let's go.
Hey, kia ora koutou. Today I'm just a video. That's because I am in Indonesia in Bali, and I don't trust my Wi-Fi reception that I have. For those of you that don't know me, my name's Tobin. I'm a data scientist with wildlife.ai, and I've been with the team for coming up 2 years now. So today I want to talk about the data science and data processing side of our project. What is it? What is the data? Where does it go? How is it stored? What's the experience for the user? And yeah, essentially what happens from once an image is captured and stored on an SD card, what is that pipeline after that? Now, disclaimer, I'm not able to cover everything today. Within a few minutes, I wish I could, but I will skim over a lot of things. But I just want to give the overall umbrella view of our project. So I'll start off with looking at the CamTrap data package. So this is our protocol that we're following to make our data internationally synced with all the other conservation projects out there. So if we're looking on the left here, we've got what's actually stored on the device level. So you can see within a deployment, you're going to have a deployment number, and then you're going to have 3 CSV files associated with them. And then following that, you've got images and videos respectively. You're going to have those single captures per animal that it tracks. Now, one challenge that we definitely have is we've got a lot of data involved in this project, and they're at different levels within the hierarchy. So we've got levels at your project level, at your deployment level, at your device level, and then at your media level. Now, how do we sync that all up? How do we handle all of that? And this is what this data package enables. So these CSV files go at the top level, and then we've got EXIF data that gets embedded into the device, and they all get synced up. That'll happen within the project within some Python scripts. So once the user extracts the SD card from the device, they'll plug it into the computer and then run these R or Python scripts on the footage and be able to generate these CSV files so they can then upload it to the respective place, which will be conveniently Wildlife Insights. So this is a third party we're tapping into. This is essentially a cloud storage host that enables people to analyze, upload, and then also share their results internationally. So you can look through other projects that are happening. You can be able to get insights into other projects and get ideas, or you're able to share your successes. Here's just some keywords that we've able to use that we've decided is a good tool for our project, and they sync up pretty well with what our goals and deliverables are, because essentially they've designed this platform around the same CamTrap conservation style design. Here is a little demo of the Wildlife Insights. So the nicest thing is that it's user friendly. It's really straightforward to use. I threw this project together in about 5 minutes, which was really nice. And you can see I am in the forest in Bali. I'm pretty in the heart of it all right now. But I was able to capture some pretty cool centipedes just today. And just be able to demonstrate a little bit for you guys. But the nicest thing is that this user interface, it doesn't have code. It's straightforward to use. They have some automatic, like I haven't run any AI on this footage at the moment, but you can see they have some automatic AI capturing for it. And then obviously you've got your metadata that I'm scrolling through now, or your EXIF data that's embedded in the image that we're able to view. Now, the nice thing about this as well is that it follows the protocol, that CamTrap data package protocol, to the dime. So we're able to have really specific information about the project, about the devices, about the deployments. And you can see that internationally, a lot of other projects are doing the same as well. So it's just syncing up, getting that clarity among different projects. And yeah, really useful tool. So that's Wildlife Insights. Now, another piece that we're using, this jumps across to the machine learning and model deployment. So what happens in that user flow is essentially we're going to be tapping into Edge Impulse. Now, Edge Impulse for us has a really strong few reasons why it benefits over some other platforms. One, they optimize their models for embedded devices. So that's really valuable for us because we've gone ultra low power and we're very limited memory resources. So to be able to have an optimized model, you know, it enables us to just keep our memory available for the other processing power that's required. The other one as well is we are using the Himax WiseEye 2 chip, and Edge Impulse offers direct support for that model. So we're able to train the model already optimized for it and already set up in the structure and the format that we need to deploy that model onto the device, which is lovely. Choice. Now, some challenges that we're coming into. Obviously, there's a lot of data and there's a lot of different moving parts throughout the project. So we trying to sync that all up definitely proposes its challenges. And the big one for me is making the user experience as seamless as possible and as smooth as possible. Now, unfortunately, we have to face the reality that we have to do some post-processing on results, and that does involve some scripts to be run on the footage. But we're looking at methods to do that as smooth as possible. And then if we take it back to the device, the devices, as I said, it's ultra low power and there's very limited memory. So we're having to look at the restraints from that. We're having to reinvent the wheel slightly to some degree for some of the way we're implementing the firmware. The device is going to be remote a lot of the time. So how do we deal with data corruption and enabling like storage between things? So like a good simple example is that if the device powers down, what actually is the process to store our data and not lose anything valuable for the user or the deployment? So yeah, there's definitely a lot of challenges along the way, but we're working through them piece by piece, and we're starting to shape up a really nice sort of pipeline for the user. Cool. I think that's sort of all I've got time for at the moment. I'm trying to keep it short but snappy. Sorry, I've skimmed over a lot very broadly, but I definitely encourage sing up with questions, send me some emails, let's have some discussions, and I can build on thoughts quite a lot. And then, yeah, we'll go from there. All right, cheers.
Amazing. Thank you so much for that, Tobin. Is there anything to add? I think that was probably explained in an amazing way.
Nah, nothing else to add, just if there were any questions. But I am jittering a lot with this meeting, so if I try to answer anything, don't expect it to be stable.
No worries. If there are no questions just yet, I can move on to the next steps first, and then we'll welcome questions about the whole segment. So in terms of the next steps, we are continuing wrapping up some final components of MVP1, mainly the communication between the device and the mobile app, focusing on transfer of the larger image files, continuing the motion sensor work, looking at power consumption in particular, as Charles mentioned, and polishing the mobile app as well to complete the start deployment flow and enable user to end deployment. So sort of trying to close off and finish off all the user workflows in the mobile app. And then we'll be able to work with some of our partners to deploy the cameras in the field once all of that's done. But at the same time, we are kicking off the MVP2 work as well, which is the rodent use case, which we'll touch on at the next showcase. And again, just want to say big thanks and congrats to the whole team. You've done an amazing job. You can see the results. It's not completely finished, but the amount of work that has come to this project and to get us that far was immense. So big congrats. Give everyone a hand. Okay, let's move on to questions. Are there any questions for the team? Or is there anything that anyone would like to add?
I have one question, which is how long are the deployments to be expected? Or like I assume a deployment is a camera goes out, camera comes back, right? Yeah, how long were they expected to last?
It varies. We're aiming for sort of a week for this use case, but potentially longer for the next use case. So a week, then maybe 30 days. Just we will just have to test the device and see what the power consumption allows us for. But yes, it just depends on the use case as well. Victor, maybe if you wanted to add anything to that. No.
2 weeks, hopefully months, but yeah, battery dependent.
Maybe I have a sub question on the topic of battery. So I guess motion detection, one problem a lot of people have is leaves and things like this. What are you looking at, or how are you trying to work around this?
Yeah, that's a good question, and indeed, even with our first product, which we called Wetter Watcher rather than Wildlife Watcher, its camera pointed to the ground and watched animals moving past left and right underneath it. There wasn't a lot of movement other than the target animal. Of course, if you moved it to point somewhere else, then potentially you can see the leaves moving, and indeed at one point we were triggering on leaves moving. So and indeed, for that matter, it will, if we're using the motion sensing camera, it'll probably trigger on shadows as well. So we may find, now of course, in principle, it doesn't particularly matter if you trigger many times, wake up, take an image, process it through the neural network, there's nothing there, you go back to sleep again. But of course, that will impact the battery life. So I guess it's a learning experience that we're going to have to go through, and there'll be some kind of sets of trade-off involving what you can point the device at, the battery life, and your positioning to avoid, if practical, movements of leaves and shadows. One of the things that we will be doing over the next really week or two is looking at the sensitivity of the motion detector. It does have a lot of parameters that can be varied, and some kind of sensitivity is likely to be a parameter that probably you'd want to make available in some simplified form to the user. So if you're looking for a large animal that's going to mostly fill your screen, then small movements of leaves in the background, you can probably remove triggers from those. So there may be some kind of sensitivity versus false trigger trade-offs to be made. That's something we need to learn.
Thanks, Jeff. And thanks, Kalindi, for the question. Are there any more questions for us? If you think of any more, you can always ask them at the end. Now we'll move on to the Spyfish project, I believe. Did you want me to keep sharing, Kalindi, or?
I can try sharing, and then we see if it doesn't work. You can come back. Okay, do you see?
Yes.
My screen? Yeah, okay, sweet. Well, welcome everybody. We'll try to be a little bit short today. And as mentioned last time, these are our objectives. Basically create this. So what we want to do is shown maybe on the left. It's we have videos of fish that of deployments where we take images of a baited, this yellow box is a bait, so fish come and eat, and then rangers review these videos and find how many fish there are, and this is used to determine the health of marine reserves. In order for this to be automated and streamlined, there are a few steps on the way. So there's the standardize the data entry already from the field, then clean up and process and organize the data that is already existing, and then develop ways to process the new data, both the incoming data and then the finding ways to do it with machine learning, citizen science, and experts, creating basically a process that makes this efficient and useful for for experts and everyone involved, and then hopefully to create like a way that automates this whole process from data to insight. So I'll show you a graph that shows or how this works. If we see this top line is basically the data that is incoming. So first, before going into the field, there's way that one needs to prepare the deployment and create like and currently this used to be done by hand and on paper and Excel sheets, but now there's forms so that whatever comes in is standardized. And then in the field, basically there's the camera that gets dropped and the deployment gets marked with location and date and so on, and characteristics like what kind of water is it and so on. And then the videos get uploaded once we're back on land. And then this creates these files of information with sites of survey and then moving information. And then afterwards, the videos get put into this classification pipeline that will be machine learning, citizen science, and then biologists. And there's these annotations that we will have then create this reporting. So this is the big picture or the process of what Spyfish Aotearoa does and will do. And now I will show you our progress with little emojis. So you can see basically these apps here are mainly done. There's a little bit of testing and reviewing how the uploading works. Then there's a lot of cleaning going on with the current where the data is and where it should go and how it should be. And we have especially this part, as you can see, there's a lot of gear emojis, the pipeline of classification. So for currently we have, like, for example, the citizen science platform works pretty well. And also the experts currently they're doing it still very manually. So it's about how to make each of these parts well, but then also to make this process. So ideally, most of the videos would be processed with machine learning, and then the things that have low confidence would be given to citizen scientists, and where citizen scientists wouldn't agree, that would be given to biologists. And then that goes into this annotations bucket, which already has some existing annotations from previously. For the reporting app here, it already exists, but with each change or fix or improvement of the pipeline further down, then like it propagates, and sometimes we need to then update whatever comes out the end. That's why I think this little gear here is going to be around for a while. And that's kind of it. I hope I'll show you this again with more green emojis in the future. And as for team, we actually have two. Oh no, where did the picture go? Well, let me try. It's gone. Let me see if I can. I can see the picture. Okay, can you see the picture now as well? Yeah, okay, so Hiromi actually used to be around a few years ago as well, so she's back, and it's really cool to see like her knowledge as well from when they were setting up the project. And then Ed joined us to help with the data journey through the project. And as last time, I really liked having that team moment where I asked the question to the team. So I'd like to do that again, which is what's a challenge or obstacle you encountered and how you figured it out. And I'll give it to you, Victor, the question. And I know Ed is around, but it's early in the morning, so you can skip the question if you don't want to. Yeah, Victor, take it off.
Yeah, I know Hiromi might be also joining, but I'm not sure he's going to be on time. But a challenge or obstacle. The setting up the dashboard, for example, has been a bit of a challenge, and as you specify, because the data is still being cleaned, and there is a lot of back and forth of like, okay, now the dashboard and reporting works, and then something happens, and then like, no, it doesn't work. So yeah, that is a challenge, and how I figure it out, a lot of trial and error at this point. But yeah, we got there. Passing it on to Ed if he wants to add anything. Otherwise, back to you, Kalindi.
Nice. I think Ed next time. Cool. And then I think that's it for me today. If you have any questions, this is our bonus video of today with this ray that gets sent away, well, gets chased away by the lobster. Because he wants to have all the food. Yeah, or she, I don't know actually. Cool. I see there's a question from Tobin. Yeah.
Yes. What are you using to generate the reporting? You said reporting app on that image. Are you using a third party, or have you guys written something yourself?
We're using Power BI because a lot of the data is or Doc is using Microsoft Suite, so that's quite like integrated into the Microsoft Suite, and it's easy for people there to use it within their suite. I think that's kind of, Victor, you can add if there's more.
Sounds good.
Yeah. And I guess we were just looking at it yesterday. It's basically once you have it set up with the data connection, then people can add things on the front end by themselves. So you don't need to have like there's buttons with graphs and stuff you can add and drag and drop into. So I think it should be accessible.
I used to teach Power BI, so if you need any help, you can just reach out.
Nice, that's good. Yeah, also just a comment on this video. This is a 10-second image. No, it's not a 10-second image, it's a video, but this is what the citizen scientists get. Basically, this is a download from Zooniverse, and then you would say max amount is here, 1 and 1 of these two creatures. Yeah, thanks a lot. And I think, Tash, it's your turn.
Right, I'm just going to share my screen. Hi, everybody. Kalindi, do you have to stop sharing yours before I can share mine, or can I just do it?
Oh, I stopped already, so I think you can.
Yeah, oh, you have? Yeah. That's all right. Oh, I share. Window. No, not those. Sorry. Tell computers aren't my big thing, eh? Here we go. I'll just bring up my screen and present. Okay, so I'm doing a Wild About AI program, which is the education program. So really our aim and goals haven't changed from previously. We're still just trying to engage students with the environment and generate excitement around AI. So this month I had the opportunity to present at a super staff meeting to some local schools. There were about 30 teachers, and it was massive. There was quite a lot of positive feedback and around the program. We generated 2 possible schools that are willing to present who are thinking about delivering the program for paid, so I'm excited about that. And everyone was just really excited about the opportunities to engage the youngest, their students with the program AI in real fieldwork, because we use Spyfish Aotearoa to do our data. So I got the created a demo version of the program that's up and running at wildlife.ai/demo. So if anyone wants to have a bit of a play, you can go for that. This month, we've also just finished recording our videos to support the resources that we've made. So rather than using other resources that are videos that have already been created, we've created our own that are subject specific. So I've been on a bit of a journey with those, so it was quite cool. I've interviewed lots of experts, and I've learned tons myself about AI and conservation and Mātauranga Māori as well, which is really cool. So a couple of weeks ago, I delivered the Wild About AI program at Stratford Primary School. It was the first time that students have had an interaction with the program. I did it over a week with 2 classes, so I did 2 days with one class and 2 days with the other class. It was just off a bit of a tangent. The students were so excited about the short 10-second videos that they could see on Spyfish Aotearoa. So they were really passionate about now seeing, like, doing the real field work. So it's a real purposeful, I don't know, task to do, which was really cool. So I set up a little feedback form from some of the students. This is just 2 of the results that I thought would be of interest. So before the program, most of them thought AI was just robots, something you used in a video game, and a tool that helps people solve, maybe, oh, what's that, a third nearly, they thought it was a tool that helped people solve problems. So I felt like the program has taught the students how to use AI in a different manner, and I really find that the bottom results is really interesting as well, that most, like, they all would either are really interested or they're a little bit interested in AI. So I think that's really a sign that we're on the right track to try and gauge their incitement, I guess, and to build that curiosity and to get the students wanting to learn more. About half the class want to be marine scientists now, so I know we must be doing something right. Yeah. So what's next? And the next, we've got a couple more weeks left of school term. So, and then moving into term 2, which is the end of April, we've got 5 classes or 4 schools presenting our program. They'll be piloting it. So they'll be just like the next step, I guess, is to seeing how other people can deliver it, because obviously I know the program. So it'll be good. I'm looking forward to having some feedback around how I can improve it, or if people are happy with the way it is. Had the feedback from hosting the program at Stratford Primary School is they've asked me to present at the next super staff meeting in May. So there's only going to be 4 of us presenting there. At the last super staff meeting there were 20, so I'm hoping to be able to garner a lot more enthusiasm and excitement and a bit more interest around other schools then. And we're going to start promoting the school to our program to other schools to try and get some more money, because that's all it comes down to, isn't it? We like that. So that's me. If anyone's got any questions. If not, that's Katie Pie.
Okay.
Hey, I do actually.
Oh, yes, you have, Lindy. Sorry, yeah, go.
This you were saying I was very curious about the form that you gave to the kids.
Oh, yes.
And especially if you had any questions about what they were thinking AI was afterwards, or is there any, do you have any more insights from that?
It's already some feedback that I have thought I need to put on the form, and I already have, as to what do they think AI is now. Yeah. But we had lots of opportunities to interact with different types of AI, so I know just from conversations that they definitely have a better understanding of AI. Yeah. Probably not to the level that you guys all do, because my level's not that high, but yeah.
Do you have any little anecdotes maybe as well from the interaction?
Oh, they were pretty. I think they saw the same video that you just showed about the stingray and the crayfish. Oh, they were just buzzing, like they were just so excited. Oh, Mrs. Coulson, look, we've got a stingray here, and what's this type of fish? And yeah, they were really trying very hard to do the right thing with the fish identification as well. They didn't want to make a mistake. So yeah, the whole thing was just really positive. So it was good. Yeah. Right.
Amazing.
Take over,
Thank you
Carolina.
so much, Tash.
That's all right.
And thank you so much, everyone, for presenting. It was amazing to see the progress, and incredible job, everyone. If there are any more questions, we can answer them. Otherwise, we'll let everyone go. And thanks for coming. Thanks for listening. We will be sharing the video from this showcase as well. So if you missed anything, you can, it was a lot of information, so you can watch it again.
Thanks for
guys.
organizing.
No worries. See you. Have a good one.
Yeah, thanks everyone. See you later.
Thanks everyone. Thanks KK for organizing.
Bye. Yeah,
Take care.
thanks. See you.